Hello students. Today we'll try to understand one neuroimaging technique, that is a magnetic resonance imaging. We are aware of CT scan, fMRI, MRI, PET. All these are different neuroimaging techniques which helps us in understanding the structure and function of the brain. So one such neuroimaging technique is this magnetic resonance imaging. As we know, in CT scans we make use of X-rays, in PET scans we make use of radioactive substances. In the same way, how does this MRI functions, magnetic resonance imaging technique functions? This MRI, it actually produces a very high resolution images of the soft tissue of the brain. So what is the mechanism behind this? MRI, it actually makes use of the magnetic properties of atoms. Like any other organic tissue, the brain is made up of different types of atoms. One such atom is hydrogen. So within that hydrogen atom, the proton is always in constant motion, which will be spinning around its axis. Okay, as it is spinning around its axis, it will be randomly distributed. Its orientation is not across a particular axis, it will be randomly distributed. So we make use of this magnetic property of the proton in the hydrogen atom. So what happens is a person will be laid down under the MRI machine, and then which produces a very strong magnetic field. Even otherwise, the earth creates magnetic field, but it will be very weak, so that it will not have any effect on the protons that are there in the brain or any organic tissue. But when this brain is subjected to a very strong or a powerful magnetic field, the orientation of protons will change. So when the person is placed within the magnetic field of MRI machine, what happens? A significant proportion of protons becomes oriented in the direction parallel to the magnetic force of MRI machine. Basically, the orientation of protons will change when they are subjected to strong magnetic field. What happens? So, what happens is when these radio waves are passed through these magnetized regions, all these protons will absorb the energy from these radio waves. So, once they absorb this energy from the radio waves, then the radio waves are turned off. So what happens then? Once it is turned off, the absorbed energy of the protons gets dissipated. How does it get dissipated? It rebounds towards the orientation of the magnetic field. I said when it is subjected to magnetic field, its orientation will be parallel to the magnetic field that is subjected. So when this absorption of energy gets dissipated through rebounds of the protons. So this synchronized rebound of several protons, it produces energy signals. So these energy signals are actually picked up by the detectors surrounding the head of the participant. So, by systematically measuring the signals throughout this three-dimensional volume of the head, the MRI system can then construct an image based on the distribution of protons and other magnetic agents in the tissue. So, this is how the image is created. The energy signals that are developed because of the dissipation of energy, they construct an image. So by this we understand MRI is a neuroimaging technique that makes use of a magnetic field and radio waves to produce computer generated images of soft tissue. So this is basically what I was talking about early. Before it is subjected to any magnetic field, it will be the protons will be randomly distributed. So second picture, it shows once it is subjected to magnetic field, all the orientation of protons becomes parallel to the magnetic field. The third thing picture that we can see is they absorb the energy from the radio waves. Third thing, when we stop giving the radio waves, what happens? The energy is dissipated by rebounding back to its orientation. Once it is rebounds happens, this dissipated energy signals are taken over or detected by the MRI machine and is then converted into image of the brain. This is how the MRI works, or the mechanism of MRI. So we also need to understand what is the difference between MRI and CT. One basic understanding what we already have is CT makes use of X-rays, whereas MRI makes use of magnetic field and radio waves. Another thing is CT scans provide pictures of tissues, organs, and skeletal structure. It gives a very gross anatomy of the gross understanding of the structure of the brain, whereas MRI gives a more detailed and high resolution images of the brain. However, CTs are all usually the first choice of imaging technique. The reason is it is much faster and easier and more economical. But MRIs are useful in instances where CT is not providing sufficient information to make any diagnosis or to understand the presence of any abnormal tissue. So especially if someone is in a lot of pain, and if they find it very difficult to hold on them for a long period of time, it is a CT that is always the first choice and not the MRI. Thank you.